Hi, I'm Randall Heyman, a mathematics academic. Welcome to my Corona Help playlists, where I make quick turnaround and free videos for people during the coronavirus outbreak. So if you'd like me to make one for you, just contact me by email or comment below any of my videos. Okay, so I've had a lot of requests for this problem, not the one that's displayed there, this one actually. Let me write it up here, 11. Essentially the last four digits of 11 to the power of 8,012, which requires us to work out 11 to the 8,012 modulo 10,000. So obviously there's some assignment due or whatever. I'm very hesitant to actually solve this. I gave some ideas in one of the previous videos. I'm going to explore them a little bit further here. But I remember when I was in first year studying, there was a lecturer who ranting about some awful person who was putting up solutions on the internet. So I don't want to be guilty of that. So what I'm going to do is just go through, I'm actually going to go through this problem, which is similar. I haven't even worked it out yet in advance or anything. I'm just going to use my trusty HP12C and go through it. And hopefully that will help you for all those people who've written to me about the problem. Okay, so I would strongly suggest you have a look at my video where I go through it all of this. Modular exponentiation made easy. In it, I say there are three basic methods. One I call the human method. Two is the computer method. The computer method lends itself a little bit more to programming. So if you're in computer science, etc., the computer method's probably going to be maybe something of more interest. And the final one is to use Euler's theorem. So what I might do, I'll just see how much time. I don't like the videos going too long. I'll do the human method, then maybe Euler, and then maybe computer if we've got time. Okay, so what do I do with the, so let's do the human method. These are just my names, by the way. They're not recognized names for how to do this. Okay, so let's go, well, 12 squared is 144. 12 cubed, I can do all these on my calculator. So now I'm going to get my calculator and work this out. I don't know this offhand what 12 cubed is. 1,728. Okay. I might use that. Why? Because, I mean, the thing that you need to realize, I suppose I should have mentioned this at the start, but I mean, if you see something that says X is equivalent to 100 mod 3, modulo 3, well, this 100, you don't need to use such big numbers. I mean, 100 is just exactly the same as 1 modulo 3. So one of my lecturers said, you need to put on, if you're in this world, you need to put on your mod 3 glasses, and whenever you see a big number, you can just reduce it to a smaller number. Now, in this case, it'll be either 0, 1, or 2, so they're pretty small. And similarly, if you had 100, if you were trying to solve this to mod 3, the first thing you would do is look through your mod 3 glasses and change that to just a 1. Okay, so I know I can, let's go back to black. I know this one here, I can just change it because we're doing mod up here, mod 1000. This is just 728, which is a little bit lower than 1,000, but I can probably do better by just going to 10 to the 4. So 12 times, 2736. So that modulo 1,000 would be 736. That's not that good. 12, 5, what happens if I multiply? 248, 832. I still don't like that. Let's do 12 to the 6. I may have to just use one of these for the human method. If this might be the best I can do. 2,985,984. Now, this is not ideal, but this 984 now is getting very close to 1,000. In fact, 984 is negative 16. So that is equivalent to negative 16 modulo 1,000. So I can now use this. So what I'm going to do is, we've got, so I'm just going to write, rather than having to write modulo 1,000 all the time, working modulo 1,000, we have, so what I've got to do is I go 12 to the 7012. Now, this 12 to the 6 is what I want to use. So if I go 7012 divided by 6, what do I get? I get 1168, and then plus a remainder of 4. So that's that. So let's actually just rub that out. That's a better way to write it. Okay, so I can now replace this by 12. Instead of 70112, I'm going to go 1168 times 6 plus 4. Why do I want to do that? Well, I'm just using all the standard rules of exponentiation or powers that we learned in high school. Yeah, high school. So this is, I can just make this 12 to the 6 all to the power of 1168. And then I'm going to make it times, I'm going to break this plus to times 12 to the 4. Okay. And why have I done all this? Well, 12 to the 6 is just the same as negative 16, which we did up here. So I can now go negative 16 to the power of 1168 times 12 to the 4. What's 12 to the 4? I've already worked that out actually. I'll just leave it here. We'll pick that up in a later. Okay, now this negative, I'm raising a negative power to a positive, an even number, so that'll just be 16 to the 1168 times 12 to the 4. So now I have to repeat the same sort of idea, but now I'm using 16. I have improved it. I've gone from a power of 7,000 roughly to 1,000. So 16 squared is, I think it's 256, isn't it? 16. Yeah, 256. So that's not really that close to 1,000. 16 cubed, 4096. Oh, that's not bad. I'll take that. I'll take that. Because that's just 96. Or should I try another one? No, I'll use that. So now I'm going to basically repeat the same thing. So what have we got? We've got 1168 divided by 3 is 389. So it's 389 times, what are we doing here? We're doing 3, yeah, we've got to do 3. So 3 plus 1. Yep. Okay, so I can now, I might just, yeah, I could do it here. So why have I done this? Because this, I'm using this. When I look at this 4,096, I just see 96 because that's the remainder when we divide by 1,000 in this sort of crazy modulo 1,000 world. So I'm just going to replace the 1168 here with 389 times 3 plus 1 times 12 to the 4. Okay, so that's 16 to the 3, all to the power of 389 times 16 times 12 to the 4. Remember, this 16 is because of that 1 there. Okay, now 16 to the 3 is 4096. And when I look at 4096, I just see 96 to the 389 times 16 times 12 to the 4. Okay. So I think I might just leave it there. If we look back, because I'm going to run out of time, and I'm not sure there's a lot of purpose in me just going through the whole process. Let's me just red pen this. This is what we started off with. So this was what we started off with. By doing the process that I've gone through, I simplified it to this. So I'll call this one 2. So if you look back, instead of having a power of 7,000, we've got a power of 1168. So we've made some progress, but we still can't work it out on an HP12C calculator. Okay, we get down to here. Once again, we can't work this out on a calculator, but it's lower than it was. In other words, this power is gradually coming down. And so it must eventually get to the point where we can work it out on a calculator. And at that point, I'll just work it out on a calculator. Okay, so that's that method. Now let's talk about Euler method. So remember the problem was, what was it? Write it up. 12 to the 7012 modulo 1000. This one was. Okay, so what I could do is I could say, now here you probably need to look at 2 videos if you want to do this method. Euler's theorem made easy. And that broadly tells us that a to the phi of 1,000 is equivalent to 1 modulo 1,000. And that's where a and 1,000, the GCD of a and 1,000 equals 1. So to do this method, you're going to have to come to terms with the phi function. So the Euler, it's called the Euler-Totient function. So you'll have a look at my video on that if you want, or source the information from someone else. Okay, so I'm familiar with the Euler-Totient function, so I would just go phi of 1,000. Well, that's phi of 8 times 125. And I've done that because they're prime powers, 2 cubed times 5 cubed. And I know the formula for this. It's 2 cubed minus 2 squared times 5 cubed minus 5 squared. This is all included in my video. So this is 8 minus 4 is 4 times 125 minus 25 is 100. So it equals 400. So this tells me, maybe this won't work because of the 12. Yeah. So in this case, it won't work. But in the case of the problem that you were given, it will work. Let's change this to 13. You can, if it's 13, then you could use Euler. And so what this is saying is, so Euler's telling us that 13 to the power of 400 is equivalent to 1 modulo 1,000. So once again, we can now use the same tactic. 400 will divide, so 7012 divided by 400. We can work out some power here. What will that be? 7012. So that's 17 plus 17 times 7012. So it's 17 times 400. So let's work that out. What's the difference? 400, 17 times 7012 minus plus 212. So then we could just do what we were doing before. Instead of, so 17 to the power of 13, sorry, to the power of 7,012 is equivalent to 13 to the power of 400, all to the power of 17 times 13 to the 212 And this 13 to the 400 just becomes 1. And the 1 to the power of 17 is just 1. So this is just 13 to the 212. So we've reduced it considerably. And from there, you could either use the human method or, yeah, in this case, the Euler method. I don't think you really want to be using it right to the end. This would have got you down very substantially from 7,000 to 200. And from then on, you just use the human method. So I've gone about as much time as I want. I hope that's useful in the problem that you have for the test or exam or assignment.